lifting gear that launch and recover the aircraft. There's also some red shirts behind me. Those are the crash and salvage personnel. And also purple shirts. And those purple shirts are what we call grapes, and they are the refuelers. They refuel and defuel all the aircraft.
During combat, red shirts handle bombs and other ordnance. White shirts mean safety officers, responsible for crew members' well-being and equipment safety. Among the most dangerous spots on the flight deck are the areas around the catapults. Nicknamed Cats, a Nimitz-class carrier's 4 catapults are on the bow and at the ship's waist or midsection. Each can rocket a plane from a standing start to 170 miles per hour in 3 seconds. Any mishap could wreak havoc, so Cat crews constantly test the system.
This catapult here, we had in a down status last night for maintenance, fixing to shoot no loads. No load is a catapult shot without an aircraft. We run the shots to make sure we have no steam leaks, everything's good to go, because we don't want to take any chances with the pilot or the aircraft.
The business end of the catapult is called a shuttle.
We have 2 steam pistons underneath this cat track. We have 450 psi of steam that builds up downstairs. When you press the fire button, our launch valves open, putting all the steam pressure behind the pistons, forcing the shuttle forward.
But shuttles alone can't get jets aloft. Warplanes need more wind under their wings than catapults provide.
And the antelope play.
This guy's either got a ton of self-confidence or he's totally nuts.
Showdown Air Combat, Sunday at 10, only on the Military Channel.
An aircraft carrier launches planes by combining catapult power with lift created by turning into the wind. Nimitz-class carriers are fast enough to hurl jets airborne in a dead calm. These vessels use their speed to develop artificial headwinds of more than 20 knots. On George Washington's bridge, Captain Erdesy and team focus on keeping the ship's direction and speed steady.
You see state-of-the-art digital displays, touch panel displays. You see displays that provide the conning officer, the person who's actually giving the orders on where to put the rudders and how to set the engines. In an instant, he can look and determine where his rudders are, how his engines are set, what course the ship is steering, how fast the ship is turning.
To turn a carrier, it takes a huge mechanism managed by machinist mate Senior Chief Paul Rodloff.
Right now we're in what's known as the steering ram room. What we have is what's called a double Rapson slide. We have 2 steering rams. Take hydraulic pressure. We'll put hydraulic pressure on the opposite ends of each ram. That'll cause linear movement of the rams. Attached to the rams is what's known as a cross member. We have a crosshead block. As this ram moves in either direction, it'll cause this cross member to rotate. Attached to the cross member in the center is the rudder post, which extends out the bottom of the ship. So we take the linear motion of the rams, causes the cross member to move. That's transferred to rotational motion, turning the rudder outside the ship.
A Nimitz-class carrier's twin rudders are enormous, 30 feet high and 22 feet wide. Each weighs 50 tons. Crew members can use either to steer the ship, even if they lose their direct link with the bridge.
The bridge loses control of the rudder, they sound an alarm. Right here, this is known as a trick wheel. What we do is we have a series of switches back here that will electrically disconnect the bridge from the steering system. We'll engage this steering wheel and to drive the ship right from here.
Deep in each carrier, from midship to stern, run massive shafts connecting her engine turbines to her propellers. To channel that power, the shafts pass through a series of reinforced chambers called alleys. On GW, Lieutenant Commander Tom Moninger oversees this alley.
Where we are right now is in 2 Bravo Shaft Alley. toward the stern of the ship. The purpose of this shaft alley is to hold the weight of the shaft and allow us to turn the screw through the water. The nice thing about the aircraft carriers is redundancy built in. We've got 4 shafts and can operate planes successfully on one of them if we need to.
The carrier's enormous power helps aviators land. To touch down, pilots count on their carriers being in a particular spot at a particular speed. Otherwise, they'd never be able to drop a 25-ton airplane onto a flight deck at 200 miles an hour and stop in 300 feet. Pilots rely on teams of landing signal officers, or LSOs, to guide jets onto the deck. LSOs know exactly what it means to land at sea. They're aviators themselves. FA-18 pilot Lieutenant Commander Christine Acton directs the LSO platform at the stern.
Up here on the LSO platform, and this is basically how this works. We've got airplanes in the air, they come around, and we land them on what we call a glide slope.
Glide slope is the downward angle a pilot must follow to land on a moving carrier deck.
The LSO is watching aircraft state, the deck statuses, the aircraft carriers, as well as what the energy state is of the airplane. The LSO can see that before the pilot's going to see that, before the airplane's going to react.
If a pilot isn't on glide slope, or there's trouble on the flight deck, LSOs trigger wave-off lights that signal the aviator to abort the landing. LSOs do their part. But in the end, a pilot traveling nearly 200 miles per hour must have the skill and savvy to snag his plane's tailhook onto a steel cable only 2 inches thick.
Right here is the number 2 wire. We have 4 arresting gear wires on board. And actually you're seeing there's 2 parts to each wire. We have a cross-deck pendant and what's called a purchase cable, which feeds down into the deck. There's an amazing amount of force being caught by these wires each time an aircraft lands.
But there's more to the arresting gear than cables. They lead down to rooms like this, where bosun's mate Steve Tate operates one of 4 massive machines that have to stop a plane cold in 3 seconds.
Basically, the aircraft lands, engages the cable, and pulls a big set of pulleys in, and it pushes this ram into this cylinder right here, and it forces all the fluid out this cylinder and out this piping right here at 10,000 psi. It flows up through here, and this is the constant runout valve. This is the heart of the arresting gear engine. This is essentially right here is what stops the aircraft. 308 gallons goes from here all the way up through here and around to this accumulator in 3 seconds.
After a cable stretches for a catch, crew members guide it as it retracts into place. The crew needs only 45 seconds to prepare the arresting gear for the next in a line of incoming planes.
Hi, it's Vince with ShamWow. You'll be saying wow every time you use this towel. It's like a chamois, it's like a towel, it's like a sponge.
Moga's enthusiasm is great.
This is incredible.
Showdown Air Combat, only on the Military Channel.
Once airplanes land on a carrier flight deck, they come under the supervision of Flight Control Center, located just inside the tower.
We could put about 3 F-14s here, 2 F-14s here, an F-18 here.
It may look like child's play, but for Lieutenant Commander Michael Singleton, this exercise is deadly serious. He's the aircraft handling officer, or handler.
It gets the most stressful when equipment goes down, catapults or the arresting gear goes down. Some aircraft has landed with an emergency or something like that, and those do happen quite often.
Manipulating scale models, the handler recreates the flight deck on an outline crew members call the